We are starting Essential Standard 9, which is surface area and volume, which both have to do with solid 3D figures. So this lesson is kind of an introduction to those solids. So first we'll start out with a polyhedron. Polyhedron is a solid that is bounded by polygons that encloses a single region of space. Remember, a polygon is made up of line segments, so a circle would not be a polygon. Okay, we have an example of a dodecahedron right here. Kind of sounds like a dodecagon, which meant a 12-sided polygon. So right here we have a 12-faced polyhedron. So the faces are the polygons that make up that polyhedron. Okay. So our cube right here, think how many faces does it have? It has 6 faces. Okay. And when 2 faces meet, it makes an edge. There are 12 edges in our cube. So every line segment where 2 faces meet is an edge. Okay. A vertex or vertice is at the meeting of 3 faces. So kind of that corner point. So a vertex here, here, here. Which means there are 8 vertices in our cube. And a base, this one right here, is how we name our polyhedron. So our base right here is a 5-sided polygon, so pentagonal or pentagonal pyramid. Here are our kind of classifications other than our bases, how we name our 3D figures. So a prism is formed by 2 parallel congruent polygonal faces called bases. And in between those bases are parallelograms. So every prism ever has 2 bases. Next is a cylinder. So we still have 2 circular bases. And then there's a curved surface that connects those bases. We'll find out next class that if we straightened out this kind of curved side and called a lateral face, it actually makes a rectangle. So if we unfolded our cylinder, we would have 2 circles and a rectangle. Since our bases are circles or circular, it is not a polyhedron. Next is a pyramid. So pyramid has only one base. One base. And then the lateral faces all meet at one vertice up top. And next is a cone. So it has a circular base and a curved surface that make at one vertice. Again, the base is circular and a circle is not a polygon again. So it is not a polyhedron. Okay. A cube is a special kind of prism. It actually does not have a base at all. It has 6 square faces. Since all of the faces are the exact same, it's hard to tell which one's the base. Okay. Otherwise, when you're looking at any of the prisms, like these blue ones, you have 2 congruent bases, one on top and one on bottom. Okay. So we look at the base. So our base is triangular, so we have a triangular prism. And it goes all the way up. We have a hexagonal or hexagonal prism. Got 2 hexagons as bases and parallelograms that connect them in between. And that could even go on to an octagonal and decagonal, and whatever polygon makes up your bases is how you're going to name your prism. Okay. All of these have 2 bases. Okay. our pyramids only have one base, and that base is how we name it. So a triangular pyramid, a rectangular pyramid, a pentagonal pyramid, and so on. So if we were classifying this picture, I would look at the base. Our base is a pentagon, so this would be a pentagonal pyramid, since there is only one base and it meets at the apex or vertice, all of our lateral faces. If we were naming our base, I would say, so our base is a pentagon A, B, C, D, E. If we were naming vertices, how many vertices are there going to be? Do that in blue. So I've got 1, 2, 3, 4, 5, 6 vertices. So if I was naming those, it would be point A, point B, point C, and so on, until I had all 6 of them named. Okay. Now if I was naming edges, remember edges are just line segments. So I'm going to start naming them. So I have A, B, the line segment on top, B, C, C, D, D, E, A, E, and there's more. We go from A to F, F to E, F to D, F to C, and lastly F to B. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 edges. And it doesn't ask us this, but how many faces do we have? We got 1, 2, 3, 4, 5, 6 faces total. And just like with polygons, how we had convex and concave, think about a concave shape. We could draw a diagonal on the outside. Well, with a concave polyhedron, we could draw a line on the outside, kind of like a 3D kind of diagonal. So try this one on your notes. You're telling whether it is or not. So it should be a yes or no. And if it is, you need to name it and find the number of faces, vertices, and edges. Okay. Go ahead and check your answers. We have 2 polyhedrons that we named by their bases. And then C was not, since a semicircle that it made up is not a polygon. Now we have cross sections. So cross sections is like playing Fruit Ninja. So you can chop the polyhedron however you want and make a cross section. So there are infinite amount of cross sections that you can make. If you can and you have time, try to go to this link and see how many cross sections you can make with each shape. Okay. So our cross section that's shown right here is actually a pentagon. Okay. But if I slice vertically, so straight up and down, I would actually have a triangle. drawn in some extra cross section, so you can see there can be a triangular one if you do vertically, or you can even do a triangular one if you just kind of chop off one of the corners. You can also do a trapezoid or quadrilateral cross section. So there are infinite amount of cross sections you can make. We have a net. A net is a diagram of a surface. Basically, if we unfolded the 3D shape, this would be a 2D kind of version of it. So this, if I folded it all up, it would make a cube. We'll see next class that it's super easy to find the surface area of a 3D figure whenever we have the net. This is another example of a net. If we folded it up, we would have a triangular pyramid. Okay. And take a second to think, if we gave you a net and we asked you how many edges does this net have whenever it's folded into a polyhedron, take a second and think about what your answer would be. So if we gave I see 9 line segments. But think an edge is a line segment formed by the intersection of 2 different faces. So when I fold this side up and this side up, that straight line and squiggly line are going to make one edge. Same with this straight line and this squiggly line, and then that straight line and the squiggly line. Okay, so there are actually 6 edges in this net.